Hello, Ms. Berkey here. This is Unit 9, Lesson 2. We are talking about arc measure today. So we need to start by talking about central angles. So a central angle is an angle whose vertex is the center of the circle. So we've got this angle right here, and the vertex of the angle is the center. When you have a central angle, the sides of the angle will intercept the circle or intersect with the circle, and they create an arc. An arc is just a portion of the circumference of the circle. So the measure of an arc is the same as the measure of its central angle. So if I have angle ACB centered at the circle's center, if that's 60 degrees, then we would also say that this arc measure is 60 degrees. Now, that doesn't tell me how long that little piece of curvy line is. That just tells me its sort of rotational measure. So the arc we would say is a 60-degree arc. So the notation we use for arcs is this. The M stands for the word measure. So this is the measure of arc AB equals 60 degrees. So the arc will tell you where it begins and where it ends. If you have, my other notation I have here is for the angle itself. So it's telling me that I start at point A, I go to point C, and then I go to point B, and that creates this angle. So we would use this little angle notation to talk about the angle at the center of the circle, and we would use this arc notation to talk about the arc. Arcs can be classified according to their size. A minor arc is an arc that has a measure of less than 80 degrees, less than 180 degrees. So like this arc right here, for example, from A to B is a minor arc because it is less than 80 degrees. A major arc is one that is greater than 180 degrees. So this arc that starts at A and goes to D and continues on to B, that is called a major arc. A major arc is more than half of the circle because 180 degrees would be half. We call an arc that is exactly 180 degrees a semicircle. So for example, if I had this arc from B to D, really good arc there, we call that a semicircle. And it is exactly 180. Half of a circle. A whole circle itself would, of course, be 360 degrees. Okay. Here is circle C. Remember, circles are usually named by their center, so the center is point C. We want to find the measure of arc AB, AD, BD, and ADB. And then we'll just say if each arc is a major arc, a minor arc, or a semicircle. So oftentimes when I'm doing problems like this, I find it easier to try to label everything in my diagram and then go through my list and write down what each of the answers are. But you can do it, in several different orders. So you find the order of doing things that works best for you. So I'm going to start with this angle, central angle 75 degrees right here. That means that this arc from A to B is also 75 degrees. BD is a diameter of the circle, so it goes from one side of the circle through the center to the other. That's a diameter. That means it's cutting the circle in half exactly. So this arc down here from D to B is a semicircle, which is 180 degrees exactly. And we have one more arc that's not labeled from A to D, so you can figure that one out several ways, but one way is to think about this upper half of the circle has to add up to 180, so to figure out from A to D, we can do 180 minus 75, and that gives us 105 degrees. Which means this angle at the center of the circle is also 105 degrees. Another way to find that is if you remember that the entire circle is 360, you could subtract the other two arcs that we already found to get that same answer. Okay, so now let's go through our list and answer our questions. The first arc that it asks for is AB, and on our diagram we can see that that's 75 degrees. Because that is less than 180, that's called a minor arc. The next one it asks for in our list is the measure of arc AD. So from A to D is 105 degrees. That's still less than 180. So that's also a minor arc. The next one it asks for is the measure of arc BD. So BD, from B to D, you could think of it as this arc on the bottom. You could also think of it as this arc on the top, and they are the same size exactly. So whichever way you rotate around that circle, that is 180 degrees. And so that is called a semicircle. Okay, our last arc is arc ADB. So starting at A, going to D, and continuing to rotate until you get to B. So we just need to add these two pieces together to get that answer. So that would be 180 plus 105, which is 285 degrees. And since it's more than 180, more than half of the circle, we would call that a major arc. Now you also could have said that it's 360 minus 75. That does give you the same answer. So that would be saying, okay, it's the whole circle, but not this piece. So that's another way of thinking about it. Okay, two arcs are congruent if they have the same measure and if they're arcs of the same circle or congruent circles. So given this diagram on the right here, arc AB, this arc right here at the top, is congruent to arc CD. Now that's because they have the same arc measure. We know that because they have the same angle. Those are vertical angles. And they're on a circle that is the same circle. They're on the same circle. So those two arcs are congruent. We also have arc AD is congruent to arc BC. And again, that's because there's these vertical angles at the center that are equal, which means that our arc measures of our arcs will be the same, and they're on the same circle, so they're congruent arcs. It's kind of easy to see if the arcs are on the same circle, whether or not they're congruent. But sometimes if the two arcs are on different circles, it's harder to tell. So they do have to have the same measure and they have to be on circles that are the same size. We're wanting to compare here arc JK and arc QR. Now they do both have a 105 degree measure, but these two, it turns out, are not congruent arcs. I could bring them next to each other and you can see their size difference. It's not a huge difference, but you can see that that second arc is quite a bit longer than the first arc. No matter how I line them up, it's just a bigger arc. And that's because it is on a circle that is bigger. So my first circle has a radius of 4, my second circle has a radius of 4.5. These two arcs are not congruent. In our second example here, we want to compare arc AB and arc CD. Now, if I do just compare their arcs directly, you can see, they are exactly the same. And that's because not only are they both a 75 degree arc, but they also are both on a circle that is the same size. We can see that the radius of this circle is the same as the radius of the second circle. So arc AB is congruent to arc CD. So for arcs to be the same, they have to have the same arc measure, and they also have to be on circles that are the same size. Okay, here's a diagram. We've got our center marked on the diagram. It's giving us a central angle of 76 degrees here and an arc of 22 degrees here. Our goal is to fill in the rest of the diagram with the other measures. So I'm going to start with this central angle right here. If that's 76 degrees, then it is also 76 degrees here. And it turns out that those two lines go through the center, so they are creating a pair of vertical angles. This one is also 76, and this arc is also 76. Okay, we have a 22-degree arc down here at the bottom, which means we have a 22-degree central angle here. All right, we've got an arc over here, BC. Well, to figure out BC, I can use the fact that this is a diameter of the circle. It goes right down the middle and cuts that circle in half. So to calculate arc BC, we can do 180 minus 76 minus 22. I have to subtract both of those arcs to get this remaining piece. Well, 180 minus 76 minus 22 gives me 82 degrees for the central angle and for the arc. Finally, we have this arc over here, almost done. This arc is also one that we can figure out using this diameter. That diameter cut the circle in half, so these two together have to add up to 180. So I can calculate this one by doing 180 minus 76. And 180 minus 76 gives me 104. So I've got everything labeled as it asked, and we are finished with this one. Okay, on this diagram, it just asks us to find one arc. Our goal is to figure out arc starting at E, continuing to F, and continuing to C. So this arc, one thing I wanted to talk about is that there are several ways that you could name this arc. That EFC is not its only name. You could have also named it arc EBC. You don't have to include all of the letters that it goes through, but if it's a major arc, you do have to include 3 letters. So I could have named it EBC. I could also have labeled it going the other direction, like CFE or CBE. So you don't always have to name it the same way. So on some problems, if you get a different name than your friend or a different name than my answer key, that doesn't necessarily mean you're wrong. Okay, so our job is to find arc EFC. It gives us this 126-degree angle here, but we can use this diameter to help us. These two arcs, or these two angles, have to add up to 180. So I can figure out this one by doing 180 minus 126. That gives me 54. And then you might have noticed that these two angles here are vertical angles. So that means this one is also 54. So to find that arc measure, we can just add those 3 arcs together. We've got the 54-degree arc, we're going to add the 126-degree arc, and we're going to add the 54-degree arc. And that gives me 234 degrees. Now, this is not the only way that you could have done this. There's several ways that you could have approached this problem. But whatever way you take, you should get 234 degrees as your answer. Okay, last one. It says we've got a circle with a central angle of 140 degrees, and our job is to solve for x. So again, look for diameters that can help you. If this is the diameter of the circle, which it is, it goes through the center, then these two angles have to add up to 180 degrees, which means this is a 40-degree angle, which means this is a 40-degree arc. So we can set up our equation as 6x minus 8 is equal to 40. We can add 8 to both sides of our equation and divide by 6 to get our final answer. X is equal to 8. And that's it, we're done. So try your assignment out. If you need help, please talk to your math teacher. Thanks.